Hi everyone. Let's take a look at the following example. The Leaning Tower began to lean during construction in the 12th century. When a tower was first built, its height was 55.1 meters. There is a specific point on the ground where you can be equidistant from both the top and the bottom of the tower. How far is this point from the base of the tower if the angle of tilt from the vertical is 4.3 degrees? Round the answer to the nearest tenth of a unit. Step 1. Draw a diagram. So right now we're going to say this is the ground. And again, I'm going to use a different color for your reference for the tower. And of course, I'll still draw this vertical line so you can see the tilt. Now, the tower is going to be somewhere there. And again, this is not perfectly to scale. I just want to give you that idea that the tower, the leaning tower, is leaning to the right. You could be leaning to the left, of course, but for this diagram, it's going to be leaning to the right. The angle is going to be 4.3 degrees from the vertical. So again, vertical is 4.3 degrees. But the goal is you want to find a point somewhere on the ground. Let's say right there. Now, what is so special about this point? This distance is the same as this distance. So if you go back to the sentence where it says equal distance from the top, this is the top, by the way, and the bottom, which is there, by the way, of the tower. So we want to find that distance, which we'll call x, by the way, which is right here, or you can say this is x, such that this is the top, this is the bottom. So one more time. Equal distance from the top and the bottom of the tower. Top and bottom, that's what you're looking for. That's it. So one more number you want to calculate, then we can go straight to step 2. If you think about this 90 degrees, this means if you have 90 minus 4.3, and again, you can grab a calculator, or you can do a little bit of mental math. I'm going to promote mental math. So I'm going to write down 90 minus 4.3 on the right top corner. That's going to be 85.7 degrees. I'm going to write down 85.7 degrees. And of course, this is also 85.7 degrees because you're looking at an isosceles triangle. And then to find the missing angle, of course, you can take 180 minus 85.7 minus 85.7. So this is going to be 8.6. So again, in case you're thinking how do we calculate that, it's 180 because a triangle, all the angles add up to 180 minus 85.7 minus 85.7 again, which would be 8.6 degrees. So now step 2 is going to be calculate x. And of course, there are many ways of doing this. I'm just going to show you one method. So notice this is one pair. And I can look at the original numbers. There's the second pair, just like that. Actually, let's go back for a second. There's one more number I forgot to add in, of course. So 55.1 is the height of the tower. So this is still going to be 55.1 meters. There we go. Let's try again. So step 2, I grab this pair and this pair, and I can apply the sine law. So of course, sine law means A divided by sine A equals to B divided by sine B. And if you think about this, A in this context is X divided by sine of 85.7 degrees. B is going to be 55.1 meters divided by sine of 8.6 degrees. Now to find x, what you have to do is take 55.1 multiply by sine of 85.7 divided by sine of 8.6 degrees. So I'm going to grab my calculator. Let's try this together. Turn it on, press clear. Make sure you're in degree mode, everybody. I'm going to press 55.1 times sine of 85.7. Divide this by sine of 8.6. And this is going to be approximately 367.4 meters. And again, it does say round to the nearest tenth of a unit. So one decimal place, just like that. If you find this video meaningful, it's adding value to your math life, please comment, like, share, and subscribe. I hope this makes sense.